This time it will be on thermal management systems, better known than heaters. The pleasure is that we have one Kevin Grout as one of the heads on our heater or thermal solution systems to present. We will talk a lot of using heaters on biopharmas as well as on other applications. I'm pretty sure it will be a very exciting talk. The official part is that I have to inform you this session will be recorded. Later on, you can recap it in our YouTube channel if you like to. And Kevin, the audience is yours.
All right. Good afternoon. My name is Kevin Grout. I work for the Integrated Process Solutions division of MKS. I'm product marketing manager. We used to be HPS back in the day. In case you recall our name, we have changed that 5 years ago or so. A lot of our business is a lot of vacuum hardware, but we also do what we call effluent management. And what I'm going to go over today is the heaters that we use in our effluent management systems, which we've been in the heater business for many years. We have a new product out today that I'm going to go ahead and go over. So we call these heaters a thermal management system because you have everything you need to plug and play a heater onto your system and manage the temperature of those heaters for your effluent management. So the Valves and Integrated Process Solutions Group is based in Boulder, Colorado. And basically, we started out with vacuum hardware many years ago, some isolation valves, and now we're into full integration. So with that integration, we do our custom manifolds that we build in Boulder. We moved to Broomfield, Colorado. We're in Broomfield, Colorado now. So we do a lot of custom manifolds that we do use into our integrated subsystems, like this subsystem you see right here. The heaters, we have 2 different materials. We have our own S49 UL controller with the latest UL ratings. We do have silicone heaters that we've been using for many years, and you will see that we are pushing those to end of life with a new product that we're pushing out today. With those integrated process solutions for effluent management, we also have a lot of traps. This over here on the right side is a water-cooled trap that's used typically in an LPCVD nitride process. The other trap here, this is another cooled trap. This is for the aviation industry that also is used to collect ammonium chloride. Isolation valves, butterfly valves, which are pressure control valves you see here. Poppet isolation valves are a large part of our product line. And then the vacuum fittings. To put the assemblies together, we use all of our own centering assemblies, our clamps and such. Those are all an IPS product. So we have a long history of heating downstream systems applications and some upstream applications too. We started out in 1995, about 5 years after I started working with MKS, and introduced a heater product line. It was basically a flat mat heater with thermostat control. We've evolved that heater along the years. We started getting away from the flat mat, and we started a molded product in 1999. Then the molded product also used thermostats, but then we transitioned over to microprocessor control. So in 2001, we came out with a Series 46 heater, which is a very common heater still today. We've moved along and we've developed new controllers with a supplier that we work with, and this is the Series 48 controller that you can do communications. You can adjust your temperatures with. Here with the Series 46, it's all fixed. So now we've evolved into being able to adjust temperatures and monitor the system to today, where we have our S49 UL system that is plug and play, and you can do just about anything with it. And that's what I'm going to go over with today. So our heater market, we concentrate on OEMs and end users, mainly in the deposition etch. We do analytical equipment, mass specs, and we do OEM new tool designs. So with our integrated products, we actually have the capability of doing full tool vacuum floor line designs for our OEM customers. We do end users, semiconductor fabs. A lot of the heaters will go into doing tool upgrades, which I've been doing for many years. So tool upgrades consist of, say, taking a TEL Alpha 8 furnace and rebuilding the floor line completely for better thermal management and better effluent management control. And in the fab. So we have many, many heaters around the world that are in the fabs, the sub fabs, the waffle floor areas. And we concentrate on a lot of that. And the new heater today is really being accepted well in the sub fab due to its communication capabilities. Other applications are, CVD, ALD, PECVD tools. We do a lot of heated products for these, but we also do effluent management where we have some traps that we can use in these systems. The system on the right here, this is actually a TIOS system where we actually have our heaters, our MKS isolation valve, MKS throttle valve, and this is a TIOS effluent trap. So this captures the TIOS. You have a furnace with a boat of wafers over here. The gases travel through the trap, catches 90% or 95% of that effluent, and then we have heated line to the sub-fab floor. Gauge trees are a really large part of what we do today. Thermal management on gauge trees is pretty important. Here you can see a couple of manometers with some isolation valves on, say, a one torr manometer. Custom trees built to be able to be thermally stable. So integrated process solutions, again, subsystem floor lines, sub-fab exhaust lines, where we do lines from the tool to the pump, from the pump to the abatement system. We also work on abatement inlet heads to improve the heating structure of these for better maintenance times and lower PMs. So today I'm going to go over our newest heater. This was introduced in 2019, of November of 2019. We are continuing to enhance the system. Today, we have our heater jacket, which is pretty common for MKS. We've been selling heater jackets for many years, but the difference here is we have two different new materials that we're using today. We're using a polyimide, and we're using a PTFE material that's not shown. The PTFE is a Teflon-based outer jacket with a fiberglass insulation, and the polyimide is a polyimide fabric outer jacket with polyimide insulation. Very clean materials, very low outgassing, very low particle levels on the materials. And then we have the MKS S49 UL controller. It's your temperature regulator. It's got, the heater actually has two type K thermocouples in there. One thermocouple feeds the temperature and your alarm bands to the controller, and the other thermocouple is used for your over temp. So there is a self checking error check to make sure that the two TCs are within 10 degrees C of each other. So that's called a health check to make sure that everything is working properly. That's your over-tempered safety, and then status indication. So there's bright LEDs in here, green, red, and yellow LEDs that tell you what the heater or what the controller is doing, what function it's working at. If it's green, it's at temp. If it's red, it's over temp. If it's blue, it's cold. And there's other status indications that you can use to troubleshoot the heater or the controller in the field. The heaters are all daisy chained in line. So if you're doing a subfab line from your tool to your pump, every 10 amps you can run a power. And after 10 amps, you would just drop in another power drop and you can continue on. There is a LTA that we use. This is called our low temperature alert. This is kind of a brain if you want to use like a dry contact, or if you want to get some kind of alarm to your tool, you can put this in line. It's an option. It goes in line in front of the heaters, and then you can read your function of your whole network. So if I have, say I have 30 amps of heaters and I have a total of 26 heaters, I would have 3 power cables. They would daisy chain from the tool all the way to the pump. And then through this LTA, I'm able to communicate to every controller on that network. Same here for the tablet. So we have an Android app that we've designed for an 8-inch tablet. I supply these tablets with the software loaded. And we'll get into that, but the tablet is kind of in a subfab. It works well because a contractor or equipment engineer can walk up to his tool. He can plug into the communications bus, and he can see every heater on that tool. So what they like today is they can plug it in once a week, walk by the tool, check out every heater on the tool, and make sure everything is functioning properly. So I'll go through these parts all in detail coming up here. Okay, the heater jackets. So polyimide, very new, promising material in the market. Today, MKS is the only one in the industry that is using a polyimide fabric. And we have the Teflon PTFE. So this is very eco-friendly. There's no fiberglass. There's no outgassing coming off of this heater, very low particle levels, so it will meet tool requirements for in the fab. So we do outfit these on some tools, and they're very clean. The PTFE is maybe not so eco-friendly because it is a fiberglass-based matting, but it is very clean on the outside. It's a very solid Teflon coating material, and it's very clean. Now we run these polyimide heaters to 200 degrees C max. We also rate the PTFE to 200 degrees C. But if a customer is interested in running up higher temperatures, then we will recommend the PTFE, and we can run up to 250 degrees C with this material. It will just limit the warranty. We have this material under test at 280 degrees C. It's been running for like 2 years, and it's browning a little bit, but it's holding up extremely well. So it's a 2-year warranty at below 200 degrees C, and then if you're going to run 250 degrees C, it's a limited warranty on that. So both heater types offer the 200 continuous operating temperatures. You can run these 24/7. They're very thin and flexible. So I've been using silicone heaters for many years. Our molded silicone heater was an absolute gem of a product. It's a very good product, but we're getting away from the molding due to the cost. But this material is really, the polyimide is very forgiving. If I have a tight spot and I'm trying to fit it in on a subfab line, and my silicone heater was just a ½ inch too long, or say 5-10 millimeters too long, I can't get it on. These heaters are very acceptable to being able to be squeezed into there and work properly. Lightweight, these heaters, both of them are very lightweight. The polyimide is about 1/3 of the weight of a silicone product. And again, low particles and low VOCs. Silicone does put off siloxanes. It has been mentioned as an issue in a lot of the semiconductor fab where they're trying to lower their siloxane output, as it does coat the lens of some of the tools in the fab, or the photoresist tools. So the lower VOCs you have, the better off it's considered. Good thermal insulation, lower power consumption. So both of these materials have better insulating characters than our silicone product. So we're able to offer lower power consumption. Square ends for better temperature uniformity. Of course, silicone heater was molded. It was a great product. It fit very well. But in bringing it over into these two products, we've made sure that every end is square so that when you butt this up against an elbow, there are absolutely no gaps. Again, self-extinguishing materials. Everything's rated CE UL today. We do custom shapes. So that's one thing that allows, this is sewn material. That's one thing that allows us is we can do custom shapes. So if I want to incorporate an elbow or a bellow into a section all in one heater, I can do that. It can help save money to a point. Okay. So let me actually, oh yeah, we can do it on this slide here. So here's your construction. Okay. Like I said before, it's a dual type K thermocouple. One is for control and the other is for overtemp, meeting your safety requirements. High density heater element. So it's nichrome wire. It's sewn into the material, the backing fiberglass material. So this is the nichrome wire, and it is sewn with an automated sewing machine into the backing fiberglass material. That fiberglass material lives right on the inside edge where it connects, where it touches to the pipe. You can't see it, but the TC is going to be located somewhere right in here, and it pushes through the pocket. So the TC only has a very thin layer of polyimide fabric, and then the TC would make contact to the stainless steel. That gets us better readings of what the actual temperature of the stainless steel are, rather than a silicone heater where we have to put that TC up into the RTV material, up a little higher into the heater, which creates a little bit bigger of an offset of the reading of the temperature controller. The materials are basically 10 millimeter thick insulation. Customers have requested that we do 20 millimeters in some situations for lower heat output into the fab and better power consumption, lower power consumption. So we can change our thicknesses, but our standard product line today is 10 millimeter thick insulation. And this is polyimide insulation here. It'd be 10 millimeters. And then your outer jacket, and then your inner fiberglass with your nichrome wire. Automated and hand sewn. So today, all of the element wires are automated, sewn in, and the heaters themselves are stitched by hand. You can see here, this is a competitor's heater where this is the element is sewn in. But one of the things that we've done is we've created nice, tight, uniform stitching with the automated sewing machine to make sure that we get a good uniform product. Speed straps. So that was kind of a little adder that we've done many years. The silicone product used snaps. The silicone product was more of a solid type of heater jacket. And if that snap wasn't properly located, it could be difficult to pull around and snap. What we have today is we have these Viton rubber straps and these Vespel plugs that we have on the heater. These are mounted into the heater fabric, and then you just simply can reach, pull, stretch the Viton strap, and hook it into place. These are also reversible if you need to get into tight spots and you need to flip it around and come around from the other side. I've had to do that. All right, our S49 UL heater controller. So this is all MKS design controller. UL certified for the latest 2012 UL out of the box use. It's UL 61010 and UL 499 and CE compliant. Safer control. It's got safety shutdown. It's got the dual thermocouples, cover control, and overtemp. So it's got overcurrent protection and voltage detection in a heater jacket. So the voltage detection is actually if we design a heater at 120 volts, but a customer tries to put 240 volts to that heater, the controller has some relays in it that relays in it that will catch that, and it will have a yellow hue and tell you that you've got the wrong voltage. Plug and play. So we do have the tablet, we do have communications, but these heaters and controllers are also meant just to purchase, say at 150 degrees C, plug in, put your heaters on, power up, and you're all set to go. Just like the Series 46. You don't have to adjust temperatures. You can purchase these from us with custom set points. So they do their own self-addressing initial power up. That would be for communications later down the road. Isolated power and signal wires. So this is one of the things where UL was a challenge. We have included our communications and our power lines in the same cable. And what that did was that forced us to create our own connector. Due to the depth of the pins and the spacing that was required for these pins. A little big on the connector, I think, something we were trying to avoid, but this is a very, very robust connector. Unlike a Molex connector you'll see on some other heaters, this connector, you can run over this with a forklift pretty much, and it's going to stay pretty solid and not cause any problems down the road. Communications is RS485 Modbus RTU. And we'll talk briefly. Right now, today, we have the tablet app. There is a Radzio software available off the shelf that you can use on your PC to communicate. And today, we are developing a gateway that you can communicate your whole line to, say, a fab PC or a fab software that we're building today, so that you can cross over from RTU to TCP and certain things like that. You can see red flashing is a safety limit alarm. So that means we've gone over a safety limit of 260 degrees here for this case here. This is adjustable. If you don't want your heater to go over 150 degrees C and you're running 100 degrees C, you can set this at 150 degrees C. And then if it goes over your safety limit alarm, it will shut down the heater. There's your high temperature alert. It's an offset value. So if I set my high temperature alarm at delta 20, that means if I'm running 150 degrees C and I hit 170 degrees C, I'm going to get a high temperature alert. Same with low temperature. Down here, it's delta 20. So if I'm at 150 degrees C, at 130 degrees C, I'm going to get a low temperature alert. And here's my actual control set point. When I'm running properly between my delta 20s, I've got a nice green light. So at 131 degrees, I'll get a green light. At 170, or 169 degrees, I'll still have a green light. Very easy to see in the subfab. And there's an array. So you have diagnostic and you have condition LEDs. Okay, so this is actually single microprocessor control. It's got dual thermocouple sensing, which you have your two TCs in your heater jacket. Your heater element, like I said, is wound into the fiberglass backing material. Spacing should be about 1/4 inch apart. Your heater jacket material, redundant safety circuitry, safety relay, control relay, the triac. So the triac is a unit that is used to shut power when the controller is switching between on and off. The triac will shut power, it'll switch its relay, and then power will come back on. That's a safety device for arcing and things like that in the controller. We have 2 voltage ranges, so 100 to 120 and 208 to 240 that we designed the heater jacket to. The controller itself is capable of all these voltage ranges. Max current for a line of heaters is 10 amps. Max current or max heater out amps for the actual controller is 5 amps. So each controller can handle 5 amps of power. So we can get some fairly large heaters up to that 5 amps. So a simple heater for 3-inch diameter exhaust line, 36 inches long, 240 volt AC is rated for 1.6 amps. Now we design those for 50% on and 50% off. You know, we try to design it for that. It will vary, obviously, depending on the conditions. Okay, so specifications, real quick, I'll kind of just zip through these. The housing materials are polycarbonate, completely enclosed. The electrical ratings, which we've discussed. Supply current is 10 amps. There is a fuse in the T-block. Something I didn't really go over, that's your power and communications bus that I showed in the first view. You've got your 100 or your 200 volt power coming in, and then power over to the heaters, and then you've got communications over to where you need to communicate. 0 to 50 degrees C in the environment. Temperature setting range. So heater control, you can set the temperatures from 35 to 200 degrees C. And in special cases where we want to go 225, 250 C, we can get those set. Temperature setting is the 1 degree C increments. One thing we do not have is PID control. We did have PID control in our Series 48 controller. Unfortunately, that just causes more problems than it does when you're just dealing with a pump line heater. You have so many variables in a pump line that PID control is really difficult to manage. IP30 for the enclosure rating, Modbus RTU RS485, the Android-based app. Ambient operating temperatures are up to 60 degrees C, minimum and maximum temperature set points. The LTA, like I said, is kind of a little bit of a brain on your communications. It's a simple, it can be used for more things than just simple, but it's basically a dry contact. So what's happening is the LTA is really the first communications line in your system. So say if I was going from a pump to my tool, I would probably hook my power into my pump and work my way up to the tool with my power. I would put the LTA right down by the pump so I could visually see it and visually get to it rather easily. He is continuously talking to the network of however many heaters you have, and he's polling them and asking them how they're doing. Are you in low temperature alert mode? Are you in high temperature alert mode? Are you stable? Is everything up to 10? Okay. And if everything's up to 10, you'll have continuity, and you'll be able to feed that line to, say, your tool alarm or any type of alarm that you want to set that up. So yeah, plug and play, very simple. The tablet app. So this is an Android-based tablet app. And basically what it's doing is it's allowing me to adjust the temperatures of that heater. It's allowing me to do some troubleshooting. It's allowing me to change my alarm bands, and it's allowing me to adjust my overtemp. Easy to use interface, very simple. Like I said, if a customer has a line of heaters and they're interested in communicating with the tablet, I will supply it with the software loaded. Simply plug it in, turn it on, and it's going to go out there and it's going to search for all the controllers on that heater network. So your first view when you plug it in will be of however many controllers you have on the system. So if I had 60 controllers on the system, I would have to just page through, and I can see each set of controllers down the line. Unfortunately, it is not incremental. So it does a pretty good job at it, but basically once it finds a controller, it locks in the address, and that could be address 2, even though it's heater 6 in the line. That's kind of unfortunate. I really wanted an incremental addressing to come out of it, but that wasn't doable. But it does self-address every heater or every controller. If I want to, I can see I've got 24 devices on my network. Today I've got 2 errors and 2 alerts. So one of the errors I can see is I've got one heater into high temp, and the other error I can see is I've got a heater at low temp. So now I can find these heaters in the line and I can start to troubleshoot these. There is a ping alert button here. So if I'm looking at, I want to look at heater number 10, I can come to my tablet, I can tap on this, and when I tap on this particular controller, it would come up here. So it says device 12 here, but the controller pops up, gives me a view of what's going on. I can see I've got a temperature set point of 65 degrees C on this controller. I've got a delta high of 20 and a delta low of 20. Everything that you see on these 2 screens is adjustable from right here. I would just tap on the temperature. If I want to change the temperature set point to 100 degrees C, I would just tap on the 65 degrees C. I get a menu that pops up. It prompts me to change that temperature, and then I hit enter, and it'll take that temperature set point, and it will remember that temperature set point from that time on. And I can change my delta C. So if I'm concerned about, getting lower than 60 degrees C, and I need to know about it, I can change this to delta 5. So temperature monitoring, control adjustment, alarm indication and diagnostics, broadcast function. So if I want, say I got a PM coming up on my tool, and I want to shut all the heaters down, I can do a broadcast function, and I can come in here and I can say, okay, everybody, drop down to 35 degrees C, and then all my heaters would drop down. I come back, I could do another broadcast function when my PM is complete, and I can bring all the heaters back up to 10. Ping, data logging. Today, we do have data logging. That's what you see right here. This is not a great function on the app because you can't save it. You can't save the graphs in your tablet due to the memory, but it is kind of a good little tool if you are working on, say you have a PECVD tool, you've got heaters right up underneath the chamber, and you're getting particle issues on your wafers. You can graph every heater on that 4 line, and you can see what it's doing and make sure that it is actually properly functioning during a process run. With the new gateway that we're coming out with today, you will be able to save all that data. It will be web-based. Field upgradable firmware. So you can go a couple slides over and you can upgrade the firmware right pull it off our website, load it onto the tablet, and then load it onto all of the heaters if we need to. Performance data, external temperatures. We all know that in order to meet SEMI S2, there are external temperature requirements depending on the type of material that you're using. It is 95 degrees C for these two types of material, the Teflon and the PTFE, and which we meet with these products, especially if we, if we use a thicker insulation, these drop down. This is 10 millimeter insulation here, but you can see at very high temperatures, we're not even close to the 95 degrees C outside temperature spec. So we meet all SEMI S2 for that. Outgassing, volatile organic compounds. I kind of briefly talked about this, but here's a little chart that shows it shows outgassing of 3 different products. So this is our silicon foam heater, this is our polyimide, and this is our PTFE. You can see it's just pretty clear that the siloxanes off the silicone are a big issue today in the facilities. Yeah, so the fabs are trying to adjust for that. They have many years, 10 years ago, I remember Samsung requesting that we don't use silicone anymore 15 years ago. It's been around a long time where the siloxanes have been a problem, where we have been able to eliminate that with these 2 materials. Oh, this slide's out of place. This is your surface temp, heater resistance of each type of material, and the power consumption. You can see that with the polyimide material, our power consumption is almost 30% in savings over a silicone-based heater. Pretty impressive. It's about 1/3 of the weight of this heater here, and yet we're still able to get 30% power savings. This is another power consumption graph. You can see actually here the PTFE actually is actually the best on our total power consumption at lower temperatures and both higher temperatures with both materials. There is a competitor out there that has a product that is very good, almost identical to ours. But it is more of a non-eco-friendly product versus our PTFE. Ours is sewn better and more solid product than this material that is used in this heater, but it does have very good power consumption. And so we've done that testing with several of our competitors. Same with the outgassing, same with the particle. This is performance data particle testing. So we get challenged many times that our heaters are putting particles into the fab. So over the years, we've developed a test method to test those particles. And what we've done is we've created a chamber. My division, we make chambers today. So we built a simple chamber that we could pull with our particle detector. Okay, so you have your test enclosure inlet, clean air from clean room enclosure enters here. So this is in a class 100 bench that we do this work. The heaters are all loaded into the bench, and then they're loaded into the chamber, and then the particle test takes place. There is a filter, a 2-micron filter here, and then your particle counter here. These are all in an enclosed housing. Everything's enclosed. We've got the controller outside. The heater is inside. You can see here's the polyimide material heating to 150 degrees C in the first 13 minutes. So the particle counter is on and the heaters are turned on. And once it reaches a higher temperature, up to 150 degrees C, it emits particles. Very low, really. Nothing's too major, mostly 0.1 micron size. And then you can see it cleans up extremely quickly, and then it no longer emits any particles off of that. So some people may require a bake-in, but typically during a tool setup, this would be disappeared before the tool started operating 100%. PTFE is basically the same thing. It cleans itself up after a certain while. Not quite as good as the polyimide, but it does clean itself up. This is a Teflon shell, fiberglass, similar to our PTFE, and we're almost identical to what we're seeing with our heater, except our heater did clean up a little bit faster. This is a coated woven fiberglass heater, very popular heater in the subfabs today of a competitor. And you can see that this heater continues to constantly output particles into the facility. Safety enhancement summary, we have the UL certification, flexible, reliable, over temp safety. We have your low temperature alert, which is kind of the brain of that part of the system. All the visual indicators that we talked about, low particles, low VOCs, the user interface with the tablet, soon to have a gateway. And for PC use today, we have the Radzio software, is what it's called. It can be pulled off the internet. The speed straps, really good, changed on that to make these much easier to install. These are replaceable too, so if one breaks, you can just replace it. Integrated cabling, so you don't have communications lines and power lines separate. They're all combined. Unvented electronics controller. So we enclose this controller completely, similar to our Series 46 from years ago. The Series 48 was not enclosed, and we did have some particle issues inside that controller. So we've gone back to a completely unvented controller. Simplified control circuitry and onboard memory with expansion capabilities, control settings and storage. So that's out. So that is it on the biopharmaceutical heaters. We have won a couple fabs, new fab builds here in the U.S. With the S49 polyimide material. It's really starting to grow here in the U.S. Unfortunately, due to COVID, I haven't been able to travel much and promote it elsewhere. Thanks to Christian, this is a great chance to get that product in front of you. I'm willing to look at some demo units if anybody's interested in possibly demoing a heater, feeling it, working the control. We can get a hold of Christian, and you're more than welcome. We'll work out what we can do to help you. The next thing is I'm going to talk about the biopharmaceutical heaters. So we do have a line of silicone heaters that we use in the biopharm industry. We've been putting heaters on filter housings for the fermentation tanks for about, it's been over 10 years now, and that product has evolved since then to probably the highest rated heater used in the biopharma industry. Okay, so in the biopharm industry, you have your fermentation tank. And typically, these tanks can vary in size. But for the most part, years ago, these were stainless steel filters. Stainless steel bases with a plastic filter in here. Your tank would vent out water vapor. And what you're trying to do with the heat is you're trying to keep that water vapor from condensing in the filter. And so we've created that product. It is a NEMA-approved product to meet industry ratings for a wash down. And that is why we have silicone for this product today, because silicone molded will meet an IP65 rating. We've taken the Series 48 controller and we've put it in a NEMA box. And this controller, 100 to 200 volt capabilities, just like the Series 49. It's got communications. You can use communications or you don't have to. The heaters are molded. They've got an really smooth outer layer that we put on the outside of these. These can be washed down with high pressure water. So can the NEMA box. This is our waterproof connectors. We are looking at developing the Series 49 control into a NEMA box today, eventually getting away from the Series 48 control, but that's not in development yet. Single-use filter application. So these are filters. They don't have the stainless steel housing, and these are like one-time use for the filter, but the heater gets used over and over again. So they have a NEMA 4-time rating for water resistance. Very easy to install. High performance for the prevention of condensation of vent gases from your fermentation tank. No bare wires. We do supply our power cables with flying leads when those get wired into a NEMA-proof box at the facility. Communication is via dry contact, similar to the Series 49 or Modbus RS45 RTU communications. So again, they're meant to stop the condensation, any clogging or back contamination of the product that would force the fermentation tank to be shut down. The primary applications are stainless steel vent filters, process filters, media filtration, and the single-use filters that we just discussed. NEMA ratings are required due to occasional spray down of equipment or adjacent components, and they often wipe them down too with like spore cleanse and things like that to clean them. So back in the day, and they still use it today, was steam jacketing. So your housing would have a double stainless steel wall. They would run steam from a steam generator over to the housing and try to keep that warm. The heater itself made it much more consistent, much more uniform heat throughout that stainless filter. We still have the snaps on here, which doesn't really seem to cause a problem with these. This foam is a little less dense than our silicone heaters we use in the semiconductor industry. Stainless steel snaps. Thermocouple is embedded into this heater mat. It's about 40 thousandths or 50 thousandths from the stainless material. Molded half-inch silicon foam, which conforms to the housing. That was the gem of our molded product. If I molded a heater for an elbow or whatever type of shape, it fit perfectly, and that's what we have today with the filter housing heaters. Water resistance with NEMA connectors and a completely water resistant enclosure. So the Series 48 is similar to the Series 49 in control and communications. You're able to adjust your temperature. You're able to adjust your alarm bands, and you're able to adjust your overtemp. It's got some LEDs, not quite as visible as the LEDs that we use in the Series 49, but you have your red, your in range, and your green LEDs that tell you where we're at in the function of the heater. Now, these heaters run a little bit lower temperature than most, so this filter for the single use, customers typically run these about 65 to 70 degrees C. maybe up to 80. You got to be careful of the materials so you don't brown it. You're not going to melt it, but it will brown it if you get too high a temp. Stainless steel filters are basically ran at 105 degrees C. So these are some of the filters. These are millipore. We actually used to make a bunch of stainless filters at my facility. We did get out of that business, but we do still support the heaters. Mostly we do single rounds for the heaters. There are a few, some multi-rounds that we do, but it's very difficult to get a multi-round heater to meet NEMA ratings because we don't have molds for those, and we really need to mold that product to get that NEMA rating. And then that's it. A lot of Paul filters, Meissner, OptiCap. So what we do is if you need a heater for a biopharmaceutical heater, you can give me the model number of the filter that you're using today, and I will size it up and make sure that we have tooling to build it, and then we can quote you a heater for that. And this is just where they are. So this is a process system fermentation tank right here, and you can see the filters basically sit on top of the tank. There's blood transfusion equipment out there and stuff that also have filters that require heat, but the main portion of our NEMA product is used in vent filters. And I believe that's it, Christian.
Perfect.
Hello?
Many thanks, Kevin.
Good.
Kevin, I have two questions. Series 49, I mean, you spoke of the upper temperature limit. Is there any experience on the lower temperatures which we can stable control? I mean, starting should we start to discuss 30 degrees, or is
Yes, you can set it at 35 degrees Celsius. Absolutely.
Okay, so basically should be above room temperature, and then you can.
Yeah, just above ambient temperature if you really want the heater to work. Correct.
Mm.
Yep.
Okay. The second thing is, in which non-semi applications would you see the Series 49? Are we talking of PECVD processes or analytics, or what is your?
It's I mean, most of its use is going to be semiconductor processing tools, etch, ALD, PECVD, and any semiconductor process that's going to have condensation in the lines that you can control with a temperature. So that could be 50% of some of the tools that go into a semiconductor fab. I mean, obviously a poly tool and other tools that don't have condensation issues, we don't need heaters, but etch, ALD, PECVD, BT, there's several processes out there that require heaters. Now in analytical, typically we are doing mostly mass specs. And that's basically what the heater does for you there is during your processing of the mass spec, it helps clean out the gases faster so that you can get down to your vacuum range with that. Okay, a lot of the facilities that build the mass specs put the heaters on them in production so that they can save a couple of days of pump down time.
Okay, good. To the audience, any questions from you? Seems like not. So, Marcia, I think we can close today's session.
Oh, okay. Well, I hope that was very thorough. And like I said, I'm more than willing to get some parts out there so people can touch, feel, test, however you'd like to go, Christian.
Definitely, we would like to do, and as mentioned in the beginning, jump on the plane and come over to Europe.
Okay. Okay. Looking forward to it.
Okay, good. Many thanks.
Absolutely.
Good. So
right.
It was a pleasure to have everybody on board. Talk to you soon. Thank you. Bye-bye.
Thank you.
Bye.
Goodbye.